Alright, in this example, we're going to use the technique of substituting a simpler identity to help you solve. So here's a trig equation. Alright, so you actually could solve this a couple different ways, but again, I want to demonstrate the technique of substituting a simpler identity. Well, you will notice that this here is on your identity paper, and that this is then equal to the cosine of 2 theta. So this theta over here, that would be your A, then your 2A, theta, the 2A would be your 2 theta. So I can just substitute 2 theta for that, and it looks a little simpler. This one actually isn't bad to solve just like that. But again, I'm demonstrating the technique of substituting a different identity. So now let's change this into our inverse function. So 2 theta, because remember this is your angle right here, 2 theta is going to be equal to the arc cosine of 0. And so I've got two places where this occurs. The cosine is 0 at 90 degrees. Oops, and I forgot to tell you again. So we're going to do, let's do this one at with degrees. I think we've done all of them with radians so far. Alright, so from 0 to 360 degrees. So the cosine is 0 at 90 degrees, and then again at 270 degrees. So because I've got two answers here, I've got to break them apart into two little mini equations. So I can say 2 theta is equal to 90 degrees, and divide by 2, and so you get, I'll move this way, there's a little more room over here, so you get theta equals 45 degrees, and likewise do it with your 270. So 2 theta equals 270 degrees, divide both sides by 2, and then you get theta equals 135. So in your final answer, you would write theta equals 45 degrees and 135 degrees. So there's an example of substituting an identity to help you solve.